Hi everyone, welcome to the bus code review. So today we're not going to look specifically at the bus implementation because the bus is really just a bunch of wires, but the idea is to browse a bit through the code that I used in the actual demo to see how this stuff are strung together. So we see that we created this bus here, and we create all the registers, we instantiate them all, and we use the bus as input and output. But by giving the bus the war descriptor like I talked about before, it allows uh, many components to output to it. Then we basically hook up all the components. Some have the bus as input and something else as output, like in this case the TMP outputs to another bus called the TMP bus, which goes into the bus 1 component, which outputs to the bus 1 bus, and this one goes into the ALU, and ultimately that goes into the accumulator, which outputs to the bus. So we have all our modules set up here. We have also our RAM, and then we have some code that's part of the demo program, but this is how everything is constructed together, and it's going to come together in this way in the final computer. I'm also going to take a few minutes to talk about the control unit. So the control unit is really just a big bunch of wiring. It's a huge module that is very difficult to debug. You can't really do a demo of it without showing the full computer, but I thought it might be interesting to look at it a bit. So we have all the connections basically that are talked about in the last part of the book. So the enable side of the control unit, the set side. Now there's a bunch of gates that we instantiate. There's wires that connect to other wires, and it just goes on and on like this. Once we've set up all of the instruction decoding stuff, then we have the wiring for the ALU instructions. For example, we use I think there's a decoder in here somewhere. Load and store instructions, data instructions, clear flag. Here we can see that I've specialized the clear flag instruction. I've restrained it to the last 40 bytes here, and that allows me to use these other conditions to do something else. Namely, I implemented a halt signal, so when the computer encounters this halt instruction, it sends a signal to this halt wire, which I can then use to do whatever I want to stop the computer. This is the stuff for the handling of IO instructions, and finally we have our jump instructions. So that's pretty much it for the control unit, so I'll see you in the final demos in the next videos.